Welcome to the Microchip Is podcast. Join your host, Mike Maynard, as he learns about the technologies, products, and people that make microchip technology what it is today.
Welcome to the Microchip Is podcast. Today, I'm learning that Microchip is edge intelligence. I'm joined by Shakeel Peera, who's the Vice President, Marketing Strategy and Business Operations. Welcome to the podcast, Shakeel. Can you tell me just a little bit about your role at Microchip?
Thanks, Mike. Thank you for inviting me to today's podcast. So, yes, my formal title is VP of Marketing and Strategy and Business Operations for the FPGA business unit specifically inside of Microchip. So, amongst other things, what I do is help run marketing, product planning, business operations, and also our applications teams. Interestingly enough, one of the informal roles that I have is being one of the exec sponsors of our corporate Edge AI strategy that is looking overall at a corporate level how we further enhance our cross-divisional product and marketing strategy around Edge AI. And I think that's probably one of the main reasons why I was asked to do this podcast. So I appreciate the opportunity to do so.
Yeah, and I'm interested. I mean, you mentioned Edge AI and we talk about edge intelligence. Can you just explain, exactly what people mean when they're talking about applying intelligence at the edge?
Right. So this is a compute model, which is basically a concept that argues that rather than just collecting raw data and passing it onto the data center for processing and decision making, that these compute operations, the analysis and decision making takes place where the data is actually being created and collected, i.e., on the edge of the network. The belief is that these are sacrosanct arguments because this kind of compute model basically results in reduced latency. There is real-time analysis of what's going on, and you can make decisions a lot quicker than passing it on to the data center. Also, to layer on top of this, there is compute and power reduction because you don't have to transport data back and forth from the edge to the cloud and back. And by the same token, you have innately increased security because data is not being exposed during transportation back and forth from the cloud. So if you take all of this, the argument is that there are innate benefits with compute chips that are now having the ability to compute with increased horsepower and are deployable at the edge. There are some estimates from Gartner and others that say it is possible that sometime soon, 75% of edge-generated data will be intelligently processed right at the source of the data rather than sending it to the cloud. The belief here is that this compute model and movement is unstoppable and it's inevitable.
I mean, that sounds, pretty compelling, and the opportunity to save costs, save power, reduce latency, increase security. I mean, that's great. But in terms of what Microchip actually does, can you give us some specific examples of these edge AI applications that might perhaps use a processor or an FPGA from Microchip?
Right. I think many people don't really equate Microchip with Edge AI and ML, but the truth is that we have one of the largest portfolios of Edge AI devices available in the market, and I think we'll talk about this a little later on. But I'll give you a few examples, ranging from the low end. Example could be machine learning or motor sensor analytics, where an MCU can help with, say, something like predictive maintenance or even early hazard warnings. We could use extracted data, pre-process it, and using model data for things like sounds, vibration, the environment, the aging history, and prior history of the operation of this machine, for example, to predict failures and prevent dangerous situations. Another example could be, and this is going up in complexity, Mike, applications like gesture or handwriting recognition. And these are deployed in human-machine interfaces. And you find examples of these in digital cockpits, in complex transportation systems, or even in shop fronts. An AI algorithm would basically use known or custom models to intelligently interpret what you're trying to convey. You could just scribble with your hand in the air and the AI algorithm basically would predict what your gesture meant or your scribble meant. And then going up even further in complexity are things like smart embedded vision. Now, this is where we are kind of unique because we are an MCU MPU company that also happens to have an FPGA portfolio. So an FPGA could be deployed to do complex object recognition and classification. You are finding increased examples of these deployed in surveillance systems, in medical imaging. For example, you have endoscopes that can go in, disposable endoscopes can go in and see, for example, a mass, and that mass could be, for example, a tumor. That will classify the tumor and age it for you as well. And another example of this is industrial computer vision systems, where you could do FA analysis for products that are coming down the assembly pipeline. So these are all examples, vast examples of edge AI applications that can be supported by the vast processing portfolio that we have in Microchip.
I mean, that's incredible, the range of different applications and the performance needed. I mean, is it too simplistic to say that these applications, typically they're trying to make sense of the real world, they're taking sensor data and then processing that? Is that really what edge AI is all about?
100%. I mean, typically what used to happen is you'd have two choices. You take the raw sensor data and again send it to the cloud and have to live with the latency for it to come back and give you an analysis for you to make a decision. Or you would do it manually, where you would just manually look at the data and try to put in an Excel sheet, try to put an Access database together, or write a Python algorithm to be able to analyze and predict intelligently. But these are all operations that can be done automatically by today's AI algorithms and done a lot faster than what could be done before, either through sending it to the cloud or trying to do it manually through human judgment.
And is it all about AI, or is it more than just AI, this increase in edge intelligence?
So it's an interesting question, Mike. So this is more than just about processing, and it's more about just deploying the AI ML algorithm itself, but also enabling the entire ecosystem. And what I mean by that is, if you envision what an AI ML ecosystem at the edge is, it is basically taking data from the sensor and being able to bridge it to the processing element. So basically, this includes providing suitable sensor and network interconnect, doing the embedded processing, doing the control function, conditioning it. And I think many people forget about this, is that edge AI is also vulnerable to security threats, whether it be cybersecurity threats or physical security threats. So providing a security infrastructure around this is also very important. So essentially, end-to-end is basically being able to collect the sensor data, transporting into the processing system, providing local interconnect, providing the cloud interconnect, being able to pre-process and condition it, and then providing security as well. All of this is basically an AI ML on the edge subsystem, and all of this is needed, not just the processing element.
And it's interesting. I mean, you've mentioned cloud interconnect a couple of times here, Shakeel. I mean, presumably what happens with a lot of edge AI is there's lots of processing out at the edge, but still there's some processing done at the data center. Is that right?
Yeah, that is correct. Not all complex processing can be done at the edge. So it is important that depending on the problem that you're trying to solve, you give the system architect the ability to do the less complex functions in the pre-processing on the edge. And for more complex functions, these can be sent back to the cloud for higher latency processing that does not need the ability to do real-time decision making. So the part of the infrastructure that I talked about before was the ability to have cloud interconnect, and cloud interconnect can range from 1 gigabit per second to 100 gigabit per second when you're trying to connect the edge to the cloud. And if you look at the Microchip portfolio, we provide a plethora of extensive solutions ranging from 1 gigabit Ethernet T1 interfaces all the way to optically enable 100 gigabit Ethernet interfaces. And you can find it all under one roof.
And I think this leads on to an obvious next question. I mean, you've talked about some of the range of products Microchip has for the connectivity side. I mean, can we just talk about, really understanding the range of products Microchip has for edge AI generally? Because you mentioned you're actually quite unique in terms of the diverse number of products you offer for this challenge.
Right. So I'm going to try and answer this question in two ways. First of all, there are literally billions of network edge and IoT devices that are already deployed in the world. When you couple this with the acceptance that these systems now or into the future will need to add intelligence to them, plus the other fact that Microchip is already designed extensively into the systems, it is basically only natural to assume that Microchip will participate or is already participating in this very important megatrend and doing so extensively. And, users will tell you this, Microchip users will tell you this, industry experts will tell you this. You can do a simple inspection on our website and it will tell you this. So this will stand up to extensive inspection. Microchip provides perhaps the broadest chip portfolio for intelligent edge processing, from sensors to radio frequency products to 8 to 64-bit embedded and control processors. We have our FPGA portfolio, and we are pretty unique from that perspective, where we provide MCUs, MPUs, and FPGAs, to what we talked about before, which is basically local and cloud networking chips ranging from a few megabits per second to 100 gigabits per second. And then hardware is just one of those elements that we provide. On top of this, obviously, we need to make all these chips and silicon products, as well as hardware, accessible and easy to use. So what we also do provide is one of the industry's most extensive ID, embedded software and solutions ecosystems that are deployable on the edge.
That's impressive. And I think also, one thing that's worth mentioning as well is that Microchip also has solutions for the data center if people are doing AI in the data center.
That's correct, Mike. So that's one of the other things I think upon close examination and inspection, what you will find is that we have a prominent data center solutions division, as well as communications business unit. And the job of these two divisions is basically to provide world-class connectivity solutions. And these are deployable to vendors and OEMs who are providing systems for enterprise, for hyperscaling. Automotive is another example, and the communications infrastructure system itself, as well as about half a dozen other business units that provide critical synchronized timing, power management, and security solutions to these data center systems.
That's amazing, Shakeel. I mean, one of the things I keep hearing people talk about on these podcasts is TSS, Total System Solutions. It sounds like edge intelligence is really a place where Microchip has absolutely got this real complete portfolio of solutions.
Mike, absolutely. I think we covered this in abstract before, but as we learned prior in the podcast, and I think I might have demonstrated this, what we provide are anchor solutions around processing and connectivity in the Z systems. And I mentioned some of them, MCUs, MPUs, FPGAs, Ethernet connectivity solutions, security systems that cover all of this. But when we surround them with critical attachments that take care of power management and timing, as an example, and sensor interface is another example, this is what we call as a total system solution. So basically, at a time when hardware engineers are at a premium, I think we all know that there are 10 to 100 software engineers for every hardware engineer, and the world is pivoting towards a resource map like that. And then the focus is around really the cost of operating systems rather than the cost of actually engineering a system. What we want to do is to help this pivot, and we want to provide ease of hardware development and providing basically an end-to-end solution with our hardware, which lets our customers focus on the pivot point that we talk about, which is adding proprietary value around software and focusing on system deployment.
And I mean, this is interesting. It feels like this TSS culture at Microchip really does make you different from other semiconductor vendors.
Right. So, Mike, I'm a little reluctant to judge other semiconductor vendors, but I think our customers and the industry will judge this ultimately. But I'm going to try anyway, right? Just objectively looking, there are very few semiconductor suppliers who provide everything from MCUs to complex FPGAs, as well as the bandwidth range that we have with our connectivity solutions. And I mentioned this, from 10, 100, 1000 all the way to 100 gigabit Ethernet and beyond for data center. If you look at just the breadth of the solutions that we provide, I think I can safely say that we cover edge AI ML with hardware processing elements as well as with connectivity very extensively. Then again, as we talked about prior, when you couple this with what we have for power management, security, and synchronized timing hardware, I think someone else can come up with a correct answer, but I think I know what it is, and I think it stands up to scrutiny.
I love that. You're very modest, Shakeel. I think it's great. I mean, you've been really generous with your time and also sharing your expertise. I mean, just a couple of questions to sum up. I mean, firstly, what do you think is the most important thing to remember about Microchip solutions for edge intelligence?
I think it's really three things. Yeah, I think three things. Three things is good. Well, let's keep it short. So the first thing, I think that it doesn't need a lot of scrutiny. The deployment of some sort of intelligence on the edge is inevitable. If you are someone who is working on an IoT platform, who is working on any kind of platform on the edge, it is a demand from your customer that you deploy some kind of intelligence. The second one will also, I think, stand up to scrutiny. You read any industry report, you will understand that Microchip's presence in these edge devices is extremely prevalent. Okay. When you combine these two facts, what we need to do is now help offer the ability for customers to add intelligence to these edge devices. And we believe that with the tremendous footprint that we have and the tremendous breadth of solutions that we have, Microchip is able to be in a position to help you add intelligence to these edge devices in a very seamless and, dare I say, a robust way.
That's an excellent and very positive summary, Shakeel. I mean, one thing we like to ask everyone who appears on the podcast, it's great to be able to talk to people with, such experience in engineering. So I'd love to know what's the best piece of engineering advice you can give the listeners.
Mike, I think one of the problems that we have for edge AI today is the ability to achieve scale. I think there's a lot of innovative ideas there, but achieving scale is the key to bring down cost as well as power consumption per bit processed. So I think the key for the engineers out there listening to this thing is they will have to look at currently available solutions, and it's dominated by GPUs, and look beyond just that as a choice. Competition is good, and competition is good for everyone. So, my suggestion for these engineers who are coming up with innovations to deploy on the edge, especially as it relates to adding intelligence, is to look at the concept of heterogeneous processing. There is no one size fits all. Depending on the problem that you're trying to solve, this could be inclusive of GPUs, MCUs, MPUs, NPUs, and FPGAs. As I said, simply there is no one size fits all. When the industry and the engineers who are striving for innovation in this field can look at this, and we as vendors can make all of these choices more accessible and easy to use, we believe that we will finally achieve scale and bring down cost and power per bit processed exponentially. So what we require of the engineers out there is innovative thinking and the ability to make using these devices easier to use and more accessible is our job. So this is, I think, the best advice I can give to engineers who are looking at edge AI intelligence and trying to deploy systems around it.
That's great advice. And if there are engineers out there that are trying to deploy edge intelligence systems, I mean, how can they learn more? What would be the best way to get their questions answered?
I think as far as Microchip is concerned, the best place to start is basically to go to our website. There's not only a discussion about our solutions, but also foundational knowledge is shared about what edge AI is and a product agnostic way of discussing what those problems are and how it can be solved. So if you go to the Microchip website and look for AI and machine learning under solutions, you will find a fairly extensive discussion on what edge AI means and what possible solutions exist out there. This will give you enough foundational information to get you thinking and get started. Or simply Google AI, ML, Microchip, and you will find resources that will allow you to kind of explore this a little further.
That's great. Shakeel, thank you so much for your time. I've really enjoyed learning why Microchip is edge intelligence.
Absolutely, Mike. I appreciate the opportunity to talk. This is a subject that is extremely relevant, and we hope that we can contribute to the innovation that's going on in this segment. Thank you so much.
Thanks for listening to the Microchip Is podcast. Please follow us on your favorite podcast platform to keep learning about the many technologies, products, and people that make Microchip what it is today. Look out for our upcoming Microchip Is podcasts and our new Beyond the Microchip podcast series.